Hi everybody, welcome to Kubernetes Leader Election for Fun and Profit. My name is Nick Young, I am a staff engineer with VMware, and I'm here to show you three things today. Firstly, what is leader election and how do you implement it, my guidelines for using it, and then some common patterns that you can use when you're using it. So, let's get straight into it. Well, I seem to have some weirdness with my slides. Anyway, here we go. So what is leader election? Well, Kubernetes leader election allows you to use the same leader election code that the API server does and other parts of Kubernetes for any of your controllers. What that lets you do is it's a distributed lock coordinated and managed for you by Kubernetes. It lets your app essentially elect one instance as the leader. And the important part here is that only one instance actually makes changes. Now, so what can you use it for? So there's a few patterns you can use it for. Firstly, this one, the basic controller pattern. Once one instance watches the Kubernetes API and writes changes back. Other instances will just be sitting there doing nothing until they become the leader. A slightly more complicated pattern is where one instance watches the Kubernetes API, takes actions outside the cluster, and then writes the result back. I'd call this an operator pattern, whereas the previous one is a controller pattern. Another pattern is one where each instance watches the Kubernetes API and only one writes a status back, maybe because the other ones are doing some sort of asynchronous operations that don't require status updates or some other sort of updates. And lastly, the catch-all bucket of other more complicated things. I've got an example of that I'll talk to you about later. So all of these things, though, let you make your app more reliable by just sprinkling that little bit of HA on it. So the important part that everyone wants to know is, how does it actually work? Well, there's an election process that updates a shared object that functions as the lock. Now, this shared object is obviously a Kubernetes object. This whole thing is built on Kubernetes. And the shared process is literally just done using the standard Kubernetes leader election code, the exact same code that the API server, controller manager, and other Kubernetes components use. The shared object can be one of two things depending on your Kubernetes version. Before Kubernetes 1.14, you could only use a config map. Well, actually, I tell a lie there. You could use the endpoints object, but that was deprecated very quickly in favor of the config map, and only the config map was recommended up until Kubernetes 1.14. Greater than or equal to Kubernetes 1.14, you can use the config map or the new lease object, which duplicates all the functions of the config map, but in a dedicated object. In the case of the config map, the info is actually stored in an annotation. For lease, it's actually stored in the spec. So that object is specifically designed to do this exact use case. It's also used for holding information about the nodes that about their leases on certain network data. So, but in either case, your app's going to need to make sure that your role has the permissions to update the type of object you're doing, either config maps or leases. The module to read the docs is here. It's client go tools leader election resource lock. That one, just the reason to check that one is it just has the details of how the objects actually get instantiated, but also if new types of object are added, that's where the code to add them is added. And there's also a interface there so that you can actually swap out this type very easily. Okay, so if you're implementing leader election and you're using KubeBuilder, I've got good news for you. It's probably already available. If you're using the generation tools, it's certainly available. All you've got to do is use the -enable leader election flag on the command line, and boom, leader election is enabled and working for you. I would strongly recommend doing this if you're running a KubeBuilder controller. If you want to have a bit more detail, or you've written your own things, or wanted to check that it's there, if you look in your new manager call, you will see some extra options that you need to add. Here they are here. There's a leader election, which is Boolean, and a leader election ID. Now, the leader election ID just ensures that your particular leader election is unique. So if you want to implement it using the old way, Informers, then it's a little bit more complicated. This one's relevant to me because I'm a maintainer on Project Contour, and this is what we do. So using informers means that you have two jobs. Firstly, getting that leader election running, and secondly, watching the channel that the leader election gives you. Obviously, sorry, I didn't say this before, but obviously I'm talking mainly about Go code here because the API server and all of the Kubernetes supporting code is written in Go. Not making any statements here about how easy this is to do in other languages. But given that, the leader election process just gives you a channel that you watch. In Contour, what we do is we start the standard Kubernetes elector. This returns an I became leader channel, and then basically you can watch that channel, and when you become the leader, that channel will be closed. So in Contour, the second thing that we do is we have a dedicated Go routine that watches when we become leader by watching that channel. When we do become leader, it fires off an update and then does nothing for the rest of the lifetime of the program. There's a few other parts of Contour that run in separate Go routines that will check the status of that channel as well. And if it's been closed, then they know that it's the leader. And they will send updates to the API server via being because they're the leader. That's how we do things in Contour, because we're using that multi-reader writer is the leader pattern. This means that all of the different instances can read from the API server, and only the leader will actually write things back. The main package for actually using this is the client Go tools leader election. That's the actual one that has all of the calls to start the leader election, to run it, some helpers, that sort of thing. That's where I'd suggest you go to do the things you need. Now, sorry, actually, I've forgotten something there. There is another example of someone doing this, but no, sorry, I put that in the wrong place. Dang. So anyway, so let's get on to the usage guidelines. This is the main thing that I need to tell you about. So my first guideline is, don't try and clean up if your instance is deposed somehow. Use Kubernetes instead. What I mean by that is, if your instance is deposed, that means that for some reason your instance became the leader, and then the properties of the object were edited by something else and made you not the leader anymore. Now, so what we need to do in that case is you need to go around and restart the leadership election again, in order to be able to make sure that that you can rejoin as a new instance. Now, you could do this in code by sending yourself back to the start, starting some new Go routines, cleaning up after yourself, doing all that sort of stuff. But instead of doing that, it's much quicker that if you do happen to get deposed as the leader, you just close down, and then Kubernetes will restart you, and you'll come up as a regular member and participate in leader elections. Maybe you'll be the leader, maybe you won't. It's a much easier way and ensures a much cleaner flow through your program. So I definitely strongly recommend it. Secondly, this is a human scale lock, not a machine scale one. What do I mean by that? Well, the default timeouts for this there's two failed checks. The leader should be heart beating its the shared object every 10 seconds, and if it misses two, then all the other things say, oh no, it's time to do another leader election, and that leader election can take sort of 5 to 10 seconds. So the total time for this from the actual leader pod disappeared to when a new pod is elected leader is on the order of 30 seconds. What that means is, don't use it for stuff that's sub 30 seconds. So if you need guaranteed leader operations happen and you can't have them disappear for 30 seconds, this is not the distributed lock for you. You should be using some other more advanced distributed locking function. The thing that it's great for is you're just running multiple pods. It's okay if whatever it's doing doesn't run for 30 seconds. And usually that's for, you're running some controller that reconciles on object entry and and maybe reaches out and does something, and it's okay if that gets delayed 30 seconds. Thirdly, be aware of what you're using your distributed lock for. I've mentioned a couple of the different patterns. I'm about to go on and talk a little bit more about them in detail, but the key thing here is you just need to make sure that you're understanding what's the key thing that you're trying to get out of using leader election. Maybe it's just, hey, I've got a simple controller and I want it to be HA. That's fine. You just got to make sure that you're aware of the trade-offs and the pieces that you need in place to do that. Okay, so let's talk a little bit more about specific patterns. The most simple one is the basic controller or operator. I sort of alluded to this a little earlier. This is one where it just watches Kubernetes objects and does stuff based on it. It doesn't present its own endpoints for anything other than health checking or metrics. And the stuff that it does could be in cluster, or it could be reaching outside the cluster. The trick is here, just use the leader lock to block the code that actually does stuff. So if you're using KubeBuilder, then a lot of this stuff is handled for you because of the way the whole framework is designed. But if you're doing something that you've written, then that's the trick. Is if you're doing this sort of basic lock, then just have the lock block the area of the code that actually does the stuff that you want only the leader to do. So yeah, as I said before, for KubeBuilders, the reconcilers are leader elected, so only one instance will actually do anything. If you haven't used KubeBuilder before, the way it works is you add any CRDs you want to manage, and then for each type of resource that you want to manage, you have a reconcile method that will take the name of the thing that has changed or been added or deleted, and it will figure out if it's been changed, added, or deleted, do whatever it's got to do, and then write any changes back to the API server. So having those things be leader elected is great. It means you can have, as I said, you can sprinkle that bit of HA on it by having lots of them running, and only one of them will be actually trying to do this at once, so you don't end up with races and locking problems there. With the informers, the easiest way is actually just to block main on becoming the leader. So you do a bunch of setup, get everything running that needs to be running, and then just start the leader election, and then just select on that channel and wait until you become the leader to actually do anything, or obviously until you receive a signal to stop. So yeah, sorry, I said that the wrong way. You can either shut down or you lose the leadership, in which case you just shut down. And that's why using Kubernetes to restart you sort of makes it super clean. Makes it really easy to understand. There's no sort of complicated cleanup logic. The complicated cleanup logic is just completely subsumed into the fact that you shut down, drop your state on the floor. Hi everyone, sorry, technical glitch there. So if you are going to lose leadership if you are going to block your main, make sure that your health and metrics endpoints are initialized first. I know this because I created some outages by adding in leader election into a service and forgetting to initialize the health set endpoint first, and so all of the non-leader processes just continually restarted because they never became healthy. So, top tip: make sure you are pretty clear on all of the things you need initialized. Okay, so another pattern is the multi-read leader writes pattern. This one watches Kubernetes objects, serves out endpoints of its own for some reason, and the leader may take actions and update objects in response. So that's what you want, the leader to be the one that's actually taking any actions and updating objects, so that again there's only one of them taking objects, so you don't end up with race problems. So Contour is an example. Contour's whole purpose is to watch Kubernetes objects and translate it to Envoy XDS endpoints. That allows Envoy machines to connect to those endpoints and configure themselves appropriately. So for Contour, every instance does that, and then the leader is the one that actually writes status updates back to Contour's CRDs. Our CRD is called HTTP proxy, and so if you create a HTTP proxy, Contour will write some information back to that HTTP proxy after it's done its parsing of it, to just indicate if the HTTP proxy has been parsed correctly and that everything is okay. If it hasn't, then it can surface exact errors and all that sort of stuff. So it's a very simple example of the sort of information that you'd write back to an object, but it sort of serves to illustrate here. KubeBuilder's webhooks are another example of this pattern, where the reconcilers, as I said before, are leader elected. Only the leader actually does the reconciling, but the but the non-leader instances can serve defaulting, conversion, and validation webhooks. So those are the ones that allow your CID to use those features. Okay, so and there's one more advanced pattern, which I thought was pretty nifty, which is a per CID leader election. Knative does this and breaks out the leader election by the object type. So I think Knative has 4 or 5 different CIDs, and so they actually have a per type CID, per type election. Sorry, and so what that does is it allows you to spread the reconciliation. So Knative breaks out the leader election by object type. So what that means is Knative has 4, I think, or 5 different CIDs, and you can split up the actual reconciliation and of each of those things across instances. So if you're running 5 instances of your controller, then you can have 5 different instances holding the lock for a particular type of CID. Okay, in summary, we have leader election is great, and you should use it for all your Kubernetes controllers, no matter what framework you're using. Queue Builder makes it really easy, but it's not hard to DIY. It's a little, I'd say it's involved, but not difficult. Let Kubernetes handle the deposed case by restarting your app is my absolute #1 top tip. And lastly, think carefully about what you're going to use your lock for. Make sure that the way that you're using your lock gives you the options that you need. If you're using it in a simple way for a basic controller, it's much easier to just make it so that you only have one instance doing any changes at once. If you're using more complicated things, it'll have necessity be more complicated. Anyway, thanks very much, and looking forward to answering some questions. Hi, everyone. I believe we're live. Hopefully everyone can hear me. So thanks very much. There's been a few questions answered in the Q&A area. Please ask more. We've got plenty of time. So I think there's only one that I haven't answered in the chat, and that's thanks, Alex, for your question about what I mean by human scale versus machine scale locks. I think that's just about how long the lock lasts for. The key thing, a machine scale lock is intended for sort of second or sub-second resolution, where you might have a file that you want to open and you only want one thing or something like that, or you want to grab a lock for some IO that you want to do outside of your cluster. I would not use leader election for that. It's, as I said earlier, it's intended for times when you've got like three or more pods running or something like that, and you want one of them to become the leader in some sort of 30 seconds or so timescale. So, and the key part is that with the default settings, the leader election will only sort of realize that a leader has gone away after 15 seconds or so, and then it'll take another 15 seconds or so to actually finish a leader election. Hopefully, sorry, I'll put that one in there. Yep. And so there's another one there from Ricardo. Distributed leader election between clusters. Oh, that's a great idea. That's an interesting idea. For that one, you would definitely need to do some sort of. You'd need to maintain your own lock outside somehow. You could probably do something similar to what the leader election code actually does. The leader election code actually just attempts to write an annotation to the config map or to update the lease object, and the first person to be able to update successfully with their update, they get the leader lock. So I would say for that, you could implement something similar yourself. I think that by default, the leader election code expects to be running in the same cluster that you're working in, so you would have to basically copy the existing leader election code. I think that's one. Does anyone else have anything? I think for me, the thing that that I have found the most useful about this thing is just that it is, once you get it working, it's pretty straightforward. Especially if you're using one of the frameworks. I only went into KubeBuilder in this talk, but most of the frameworks have some support for helping you make this a bit easier. But even if you don't, it's not too hard to get it running. And once you do, it does just let you make things a lot easier. Well, seems like there's no other questions coming in. I guess we can. I will be online in the custom extend Kate's list channel on the CNCF Slack, ready to answer any other questions you might have. Thanks, Mike. That's really nice. Mike just thanked me for the useful talk. And please feel free to hit me up either on the CNCF Slack. I'm Young Nick there. You can hit me up on Twitter at Young Nick, or on the Kubernetes Slack. I'm also Young Nick. So with that, I think we're done. Thanks very much, everybody, and look forward to seeing you around the traps.